I am Michael Spashevsky, and this is Sofia Lake and I's Shake Table Lab. As you can see, this is our building sketch. This did not compare with the final product of our building. As you can see, there were building codes. One of them was that each story had to be at least 18 centimeters high. We thought that our building was only going to be 36 centimeters high, but it turned out to be a lot higher. As you can see, these were our first attempts at the base of the building. We built the support beams for the first pillars of the building. These beams would help our structure be more stable. We then built the second story of our structure. Along with the second story, we put in the cross beams for each opening on the building. These cross beams support some of the building's weight, which would help keep the structure sturdy and strong. Our structure had then its first middle pillar in. The middle pillars add extra support to the center of each level. They would support each story's weight with the sandbags and would keep the stories from collapsing on each other. Here we were putting on the roof of our building. The roof was supposed to separate the buildings in their own unique ways. We are 25% finished with the roof in this picture. As you can see, this is the final product of our building. It reached an amazing height of 88.9 centimeters. Each story was 18 centimeters high. This height did not compare to the original design. It is much taller than we expected. As you can see, this is static testing. Static testing is where you put 2 sandbags on each story of your building. Each sandbag weighs 250 grams. If your tower survives for more than 10 seconds, that means it has survived static testing. Strengthening, one of the most important parts of the building was beefing up the tape on the corners to fortify them. We also made sure to put extra tape on the X's so that they would not give out. Some of the strongest parts are the stories on each level, held up by pillars from different angles. Another one of the strongest parts are the X's on each face of the building. The X's are held together by tape and are hard to break or bend. X's make 4 different triangles, which are a strong geometrical shape that can help support the building. Our weakest parts of the building are the crossbars. The crossbars don't have much support, which can cause them to be weak and bendable. Bendable parts could be devastating to the structure because they support some of each story's weight. Tape was crucial in our building process because it helped secure and connect most of the straws. Tape also helped in the corners of the building because it held together the 2 straws to make a joint. As you can see, we took the advantage of unlimited tape on the corners. In our building, we had extra supplies. We used a sheet of construction paper for the flooring on each story. The cardboard square on the bottom helped evenly support the building and made it easier for us to build off of or to start a structure. Construction paper was also used along with a few extra straws to build the unique design for the roof. Here, our tower is holding 12 sandbags in total. Our tower is attempting to hold 20 sandbags. As you can see, this is the XYZ graph. The Z, or the blue, stands for the up and down movement. The orange, or the Y-axis, stands for the forward and backwards movement. And the green, or the X-axis, stands for the side-to-side motion. Hi, I'm Michael Spashevsky, and this is Sofia and I's Shake Table Tower. Our tower held a total of 18 sandbags, 9 on each level. The parts that failed the first were the side pillars and the cross beams. If I could do anything to change about this tower, I would definitely reinforce them with tape. If I could reinforce the cross beams and the side pillars with more tape, our tower probably would have held another round of sandbags. What I learned about making an earthquake-proof building was that you need to have a strong base. If you don't have a strong base, then all of your stories will collapse. Again, if the top story collapses, it's fine. You could just put the sandbags on the bottom story. But if the bottom story, the base, collapses, then the top story will fall down with it. I had a lot of fun with this project. Probably the most fun part for me was watching our tower collapse and watching the tower just survive so many rounds of sandbags and just having that adrenaline rush. Thank you for watching.
Hi, I'm Sophia Lake, and this is the tower that Michael and I built. It was able to support 18 sandbags, almost breaking the record. The reason why it fell down was because the supports at the bottom started to bend, and the entire tower started leaning on some of the cross beams. If I wanted to change that, I would have added more supports on the bottom so that the entire weight of the tower wouldn't lean to the side. I learned that using some of your extra materials, you can have your tower last for much longer. We used some of our extra straws to create the supports on our base level and second level. My favorite part was that watching our tower pass by so many rounds of shaking. Thank you.